Right, hi there. I'm just going to talk through all the straight line exam questions that I give you for homework, just to make sure that if there's any issues, you've got somewhere to go to get help. Okay, so this is the first one here. The line AB makes an angle of pi over 3 radians with the y-axis, as shown in the diagrams. Find the exact value of the gradient. Okay, so we're asked for the gradient, and we've been given an angle. Now, as soon as you're working from a gradient and the only information you have is about the angle, you're going to be using tan theta. The important thing about this theta though is it has to be the angle with the horizontal. Now, most of the time that's the angle with the x-axis. So it has to be that angle there with the positive direction of the x-axis. That's going to be your theta. Now, we use the x-axis to show it, but in actual fact what it is always going to be the angle with the horizontal. So all we're going to do here is say, right, well, it's this angle here that is going to be our theta. So pi over 3 is really 180 divided by actually 60. Because this is vertical and that's horizontal, the whole thing has to be a right angle. So this theta here has got to be 30. Okay, working in degrees where, because I know you guys like to work in degrees wherever possible. And then that tan 30, that's an exact value. This will be a non-calculator question. So the exact value for tan 30 going to your triangles or your table is going to be 1 over root 3. Okay, now 3 marks here. One for knowing to use this horizontal angle first. So for the strategy for getting that. So basically for getting that 30 degrees or pi over 6. The second for getting tan of 30. And then the third is for getting the exact value to the answer. Okay, the second question here, a very typical question, finding the equation of two different lines and then the equation, the point of intersection between them. So the first equation is the median of CM, or the median CM. So median always meant the middle to us. So this is all about this point here being the midpoint. Okay, so exact halfway point there. Okay, now it's not necessarily going to be at right angles because it's not an altitude, it's going to the midpoint. So we need to find that point M first before we can proceed. Okay, so for A, the midpoint is going to be the two x coordinates added together. So negative 4 add 12 halved, and then 1 add 3 halved. So the midpoint M is going to be, well, 8 over 2, which is 4, and 4 over 2, which is 2. Okay, then we've got these 2 points now, so we can get the gradient of that line. So the gradient of MC, remember to be very clear about what you're finding the gradient of. And that's going to be negative 7 subtract 2 over 7 subtract 4. So that's negative 9 over 3, so it will be negative 3 for that gradient. And from there, we've got 2 points on the line. We've got C or M. I would use this point M because we've got no negatives. We know the gradient, so it's y minus 2 is equal to minus 3x minus 4. So y is equal to minus 3x. Minus 3 times minus 4 will be plus 12, and then adding 2 to both sides will be plus 14. Okay, so that's your median. I'll do all the marks at the end if you just bear with me. For B, we're talking about an altitude. Now your altitude, just like a height, has to hit the opposite side at 90 degrees. Your measure your height always in a straight line and perpendicular to the ground. Same with altitudes. Okay, so we've got a point on the line already. That'll be our point. We just need to know the gradient. And the trick here is that it's perpendicular to the gradient of BC. So the gradient of BC, 3 subtract negative 7 over 12 subtract 7, so that's 10 over 5, which is 2, which means the gradient of your perpendicular, or in this case the altitude, is going to be negative 1 over 2, and that's, since 2 times negative a half is equal to negative 1. Okay, we've got the gradient, we've got our point, so now it's going to be y minus 1 is equal to negative a half x plus 4. Okay, which means y is going to be negative a half x, negative a half times 4 is negative 2, add 1 is minus 1. Okay, now that's our two lines. That's the equation of the two lines we've got. Find the coordinates of the point of intersection. So that point of intersection is the point where these two lines meet. So that has to be solved through simultaneous equations. Any point of intersection we know is going to get solved through simultaneous equations. So these are both equal to y, so we can make them both equal to each other. Is equal to negative a half x minus 1. I would times everything by 2 just because I've got a fraction that I'm not a massive fan of. So minus 6x plus 28 is equal to negative x minus 2. And then just collect your x's, collect everything together. That's going to be 30 is equal to 5x. So x is 6. And we know that y is equal to, well, let's just use the minus 3x plus 14. So minus 3 times 6 is negative 18, add 14 is negative 4. So the point of intersection is 6, negative 4. Okay, let's look at marks. Okay, so for part A, we're looking at a mark for the midpoint, a mark for the gradient, and then a mark for using y minus b and simplifying to y equals negative 3x plus 4 or equivalent. In B, there's a mark for the gradient of 2, a mark for the gradient of negative a half, and then a mark for getting your way to the simplified equation as well. And then for the last one, there's one for setting up your simultaneous equations, one for solving for your x, and then the third for solving y and giving your point of intersection. Okay, doc. So question 3. Okay, again, very similar question. This time they've not given you the lines to look at, so they've not given you as much guidance for that. Okay, first we're looking at the equation of line P, the median from C. So again, we're talking about a median, which means the middle, so it has to go to the middle. It's from C, so it's going to leave C, and it's going to come across here and hit the midpoint, let's call it B just now. Okay, now forgive my very wonky line. Okay, so for part A, D is going to be the midpoint of AB. So minus 1, add minus 3 or 2, and then 6 add negative 2 over 2, which is negative 2 and 2. Okay, so there's your midpoint. Now we need the gradient of DC. Right, you should hopefully see that because they're both too high, this is now the point minus 2, 2, and that's the point 5, 2, that the gradient is going to be 0. Okay, but that will come from your y2 minus y1 anyway. And because the gradient is 0, your equation is just going to be a y equals, because the only thing that horizontal line is going to have in common is the y coordinates. So your equation is going to be y equals 2. Okay, now that will still work using 0 in your point, using y minus b equals mx minus a. The time that it won't work is if you've got a vertical line, so you just need to be careful with that. Okay, so B, we're looking for the perpendicular bisector of BC. So the clues are in the name. Perpendicular means that it's at right angles, and bisector means it cuts it exactly in half. So it's going to come up exactly at right angles to that line and exactly in the midpoint. Okay, so we need to do both here for the perpendicular bisector. Okay, so the midpoint B of B and C, let's call it E just now. Okay, and you don't have to be calling it that, but just to make it very clear. It's going to be negative 3 add 5 over 2, and negative 2 add 2 over 2. Okay, which equals 1. That's not a very good bracket. 1, 0. Okay, the gradient of BC now, so that's us got our point on the perpendicular bisector. We now need our gradient as well. So the gradient is going to come from being perpendicular to BC. So the gradient of BC is 2 subtract negative 2 over 5 subtract negative 3. That's 4 over 8, so it's a half, which means the gradient of the perpendicular, excuse me, sorry, Apologies, stupid update. Doesn't matter nothing. Okay, so the gradient perpendicular is -2 or 1 or just -2. Since -2 times a half is -1. Okay, and then we've got our gradient is -2. We've got our point is 1, 0. Okay, just be careful you can't use B or C because it's not on the line, the perpendicular bisector. So it's y take away 0 is equal to -2x subtract 1. Okay, which just simplifies to -2x plus 2. Okay, and then again, we're just looking in part C for the point of intersection. So we've got them both equal to y. So it's -2x plus 2 is equal to 2. Okay, which solves, subtract 2 from both sides, -2x is 0. So just x is 0. So the point of intersection is 0, 2. Okay, now that's the one I made a mistake on when I gave you the answers written out. Okay, so just don't panic if you're not agreeing with it. Or I didn't agree with it originally. Okay, so we've got kind of generous and marked one here, one for the midpoint, one for the gradient, and then one for the equation. Okay, in part B, one for the midpoint, one for your gradient, one for your perpendicular gradient, and then one for the equation. And then last one, just like always, one for setting up your simultaneous equation, one for solving for x, and then one for giving your point of intersection. Okay. So next one here, we're looking at finding the side of angle A that the line joining the points A and B makes with the positive direction of the x-axis. Okay, so again, we've got this positive direction of the x-axis popping in. Okay, now as soon as we're seeing that, the one big area, that angle there with the positive side of the x-axis is when you're using m equals tan theta. Now that means if you know the angle, you can calculate the gradient, but it also means if you know the gradient, you can calculate the angle. Okay, and here, because we have the two coordinates, we can calculate that gradient. So we're going to do that. MAB is going to be 2 subtract -1 over 3√3 subtract 0. Okay, just using a y2 minus y1. So 2 minus, or 2 subtract -1 is 3. 3√3 subtract 0 is just 3√3. And then we've got 3 and 3 on the bottom, so they'll just cancel out to 1 over √3. So I know my gradient is 1 over √3, so that means I can sub that in and work backwards to find theta. So theta is just going to be the inverse tan of 1 over √3, or what angle do I tan that gives me 1 over √3, and we know from our exact values that's going to be 30 degrees. Okay, so theta is 30 degrees. Okay, so let's just have a look at the marks here. Much quicker one there, which is nice. So the first one is for getting your gradient is 1 over √3. The second one will be for substituting into your m equals tan theta. And your third one will be using your exact values to calculate those answers. Okay. So number 5, I believe. Okay, so part A, bit of an unusual question, but that's fine, one we can cope with. Show that the triangle is isosceles. So we know that isosceles triangles have the length of two sides the same. Okay, so we need to show that in here there's two sides that are the same. Okay, first thing to say is along that bottom between B and C, you can see that they share the same y coordinate, 2 and 2. So the length of that side is just 6 along the bottom, okay, because it's between 1 and 7. Between A and B, or the side AB and the side AC, that's just going to work from getting the triangles. So in there, we've got a triangle BA, or BA there, and that goes between 1, 2 and 4, 8. So that's 1, 2, this is 4, 8. Put them on the other side of the letters here, sorry, just to get a bit more space. So along the x direction between 1 and 4, we know that is 3. And the y direction between 2 and 8, we know that is 6. Okay, so there, this length here, let's just call it a, well, let's just call it the magnitude of AB. We'll keep sneak a bit of it because I'm without you thinking about it. So the magnitude of AB, the length of that line, is going to be 3 squared plus 6 squared, which is 9 and 36, which is root 45. Okay, and then just doing exactly the same thing between A and C. A is still the 0.48. C is the 0.72. So there you're going between in the x direction 4 and 7, which is 3 again, and then still between 2 and 8, which is 6. Okay, so I'm going to be very thorough here just to make sure I'm doing that properly. So again, just the size there is the magnitude of AC, which is 3 squared plus 6 root 3, which again is root 45. Okay, so the magnitude of AB equals the magnitude of AC, which does not equal the magnitude of BC, therefore isosceles. Okay, now that is a very, very thorough explanation for 2 marks, but I just want to make sure I'm being clear about that so you can follow it. Okay, so BI, quite a big question. The altitudes AD and B intersect at H. Okay, so the altitude AD will come from the point A and hit this side at 90 degrees because altitudes are like heights. And BE is again the same. Okay, it's coming from B, but it's hitting over here at right angles, so at point E, and this is point D here. Okay, so let's look at AD first. Firstly, you need the, well, we've got a point already, we've got A, so we need the gradient, and the gradient is going to be perpendicular to BC, because we know BC is horizontal. So let's look at this, let's look at AD first. So the gradient of BC is 0, which means actually that AD is undefined. Okay, so the gradient of AD is undefined, which means we can't use y minus b equals mx minus a. We just need to say, right, well, in that case, a vertical line is going to have the equation x equals, because we know that's the only thing that all those points on that line have in common. In this case, because a is 4/8, x is equal to 4. For the altitude of BE, well, firstly, the gradient of AC, because again, the only thing we know about the gradient of BE is that it's perpendicular to AC, is going to be 2 subtract 8 over 7 subtract 4, so negative 6 over 3, so negative 2, which means the gradient of a perpendicular is equal to positive a half. Again, since minus 2 times a half is equal to minus 1. Okay, so this is our gradient here, a half. We know the point B is 1, 2. Okay, so B is 1, 2, which means you can jump into y minus b. Sorry. So y minus 2 is equal to a half x minus 1. Okay, so 2y minus 4 is equal to 1 times that bracket, so just x minus 1. So 2y is equal to x plus 3. Okay, and then it's asking again the h for the coordinates of h, well, that's where these two lines intersect. Okay, so we've got two equations here, x is equal to 4 and 2y is equal to x plus 3. Simultaneously, well, we don't have y and y, but because x is 4, we're just going to substitute in. So the point of intersection is going to be when x is 4, so 2y is equal to 4 plus 3. So 2y is equal to 7, so y is equal to 7 over 2. So h, that point of intersection, is 4, 7 halves. Okay, and the last one is a bit of a, again, a bit of a strange one, and I'm just going to put it over here just so you can see the question the whole time. Okay, so for C, hence show that h lies 1/4 of the way up dA. Okay, so we've got D and A and H. Okay, firstly, they're all in a vertical line, so they share the same x coordinate. They're all x equals 4, but we know that. So D we know is 2 high. We'll just look at the y coordinates. H we know is 7.5 high. And the A we know we're 8 high. Okay, so it's to show that that's 1/4 of the way up. Okay, now the total distance is 6. Okay, so that's A, H, and D. Okay, so A to D, or the magnitude of D to A, is 6. Okay, 1/4 of 6. Okay, so 1/4 of the way up the line will be 1/4 of 6, which is 1.5. So 1/4 of 6 is 1.5, or 3/2. So for H to be 1/4 of the way up that line, we have to be 2 plus 3/2. That's 4/2, and 3/2 is 7/2, which matches up to H. Okay, so this matches, therefore they are the same. Okay, so to look at marks now. Okay, going back to A. Okay, 1 mark for root 45, and 1 mark for then showing it's isosceles. So 1 mark for your statement. For B, you're going to get a mark for x equals 4, just for that equation. You're going to get a second mark for your altitude BE for the gradient being -2, a third mark for then the gradient being 1/2, and a fourth mark for the equation of your line, whether it's in this form or with halves. Okay, your fifth mark is for setting up your simultaneous equations by subbing 4 in. Your sixth mark is for getting 7/2, and your 7th mark is for putting the coordinate. Okay, and for C, it's just a proof that makes sense just for the mark. Okay, so showing that you know it's 6, 1/4 of 6 is 3/2, and then add the 3/2 down the bottom takes you to where you need to go. Okay. Okay, so 2 more questions to go. Sorry, it's quite a long video. Okay, so the lines y equals 2x plus 4 make angles of A and B. Okay, again, they're both with the positive direction of the x-axis. Find the values of A and B. Okay, so firstly, we know that these angles here, because they're both the positive direction of the x-axis, are both closely related to the gradient. Now, we don't have any points to find gradient, but what we do have is the equation of the lines. Okay, so for y equals 2x plus 4, we know that the gradient's 2 because of y equals mx plus c. So the gradient of that line's 2. Slightly differently for the other line is x plus y is equal to 13. Well, we know we can't lift out the gradient unless it's y equals. So y is going to be negative x plus 13, which means the gradient is -1. Okay, now we're now going to use our m equals tan theta. So we know that m equals tan theta, so 2 is equal to tan of A. Well, let's use A this time because that's actually what we're using in the question. Okay, so A is going to be the inverse tan of 2. Similarly, we know that -1 is equal to tan B. So B is going to be the inverse tan of -1. Okay, so inverse tan of 2 is 63.434. So let's just call it 63 degrees. Okay, and then the inverse tan of -1, well, we know the inverse tan of 1 is 45 from our exact values. Okay, but that's going to be your acute angle here. So in the second quadrant where this one is, it's going to be 135. Okay, which means for part B, hence find the acute angle between the two given lines. Well, we know that's 63 and 135 here. So that's 63, that's 135. That makes in here 45. So 63 and 45 is 108, which means this one here is going to be 180 take away, which is 72. Okay, so for part B, we're talking 72 degrees. Okay, so marks again, just before we go into the last question. Okay, first one is for knowing the gradients 2, second one for 63 or 63.4. The third one is for gradient being -1 because you've got the extra skill in there, so it's an extra bit of knowledge I get a mark for. And then the fourth one is we're getting 135. And then the fifth one is just we're getting 72 degrees. Okay, so last one, find the equation of the line AD. Okay, so ABCD is a square. Okay, key point there, we know squares are all the same length side and also all right angled. A is a point, the coordinates 3, 4. And ODC has equation y equals half x. Okay, so find the equation of the line AD. Now, as always, the equation of the line is always going to be y minus b is equal to mx minus a. We have a point. Okay, we know the point A, which is 3, 4. We just need to know the gradient. Now, the only information we have about the gradient here is that the line ODC has the equation y equals half x. So the gradient of OC has to be a half. And because it's a square, they have to be right angled. So the gradient of AD, which is the perpendicular, has to be -2. Since, again, half times -2 is equal to -1. All these examples are picked certainly like that one. Okay, and then you're just good to go. So y minus 4 is equal to -2, x minus 3. So y is equal to -2x. -2 times -3 is +6, add another 4 is +10. Okay, find the coordinates of D. Now looking at where D is the point that is on both lines there. Y equals half x and the y equals -2x plus 10. So for part B, it's the point of intersection between those two lines. So it's a half x is equal to -2x plus 10. That's just times it by 2, get rid of fractions when we can. So x equal to -4x plus 20. Add 4x to both sides, so 5x is 20, so x is 4. And then we know that y is equal to half x, so y is equal to half of 4, which is 2. So D, the coordinates of D is 4, 2. Now C, find the area of square ABCD. Okay, we know the area of a square is given by just line times breadth, or in the case of a square, because they're all the same, the length squared. So we just need to know the length of one side. Okay, and because we know those 2 points, 3, 4, and 4, 2. Okay, and here we know the point at the top is 3, 4. We know the point at the bottom here is 4, 2. Looking along the x direction between 3 and 4 is 1 space. Y direction between 2 and 4 is 2 spaces. So that's going to be a length. So the length is the root of 2 squared add 1 squared. So that's 4 add 1, which is 5. So that's root 5. So the area is root 5 squared, which is just 5 units squared. Okay, looking at the marking. Okay, so last question. So in the first one, you're getting a mark for identifying the gradient as a half. A mark for then identifying the gradient of your line is -2. And then a third mark for y equals negative 2x plus 10. In part B, 1 mark for setting up the simultaneous equation, 1 mark for 4, 1 mark for the coordinate of D. And then in C, you're getting 1 mark for finding the length and then 1 mark for giving the area. Okay, so just over 30 minutes. What a beautiful 30 minutes of maths you have to watch. Thank you for your time. Bye now.